Okay, so today we are going to be working with functions, all right? And there are a lot of different ways that we can express a function, but basically here's the deal. A function is kind of like a mathematical machine where you put a certain number in and that function's going to do something to that number, and then it's going to give you a different number coming out. So maybe you put in 2 to this function and you're going to get out 10. And then you put in 3 to this function, you're going to get out 15. Then you put in 4 to this function, and you're going to get out 20. All right, so there are all different kinds of ways that a function can work, but basically every time you're putting a number in, that function is going to do something, and then it's going to put it out. And so working with functions is a lot about just working with what we put in and what we get out. Now, there's different ways that we can express these. In number 1, it says to represent the data in the table using each of the following. The first one that we're going to do is a mapping diagram. Well, to do a mapping diagram, all we have to do is take 2 circles, 2 ovals, and in the first oval, we're going to put the data. So over here, you can see the data, the time in seconds, and in the second oval, we're going to put the dependent data, which is the height. So we have independent in the first, dependent in the second. Another way to think about it would be X data in the first and the Y in the second. So let's go ahead and do this. We would have 0.0 for the first time, 0.1, 0.2, 0.3, and 0.4. Now the height was 10, 9.8, and you know what? I think I'm going to rearrange these and put them in order from smallest to largest. So I'll go 7.4, 8.6, 9.4, 9.8, and 10. All right, so we've got the data written in. Now all we have to do is draw a line connecting the data that goes together. So for example, the data is at 0 seconds, it was 10 feet tall. So I'm just going to connect those two, or 10 feet high. The second one, at 0.1 seconds, it was 9.8. So we'll just draw a line there saying that those two go together. At 0.2 was 9.4 seconds. 0.3 was 8.6 seconds. And 0.4 was just 7.4 seconds. So we're just going to draw a line from the X value to the Y value, from the input to the output, from the independent variable to the dependent variable. So that is a mapping. That's how you do that. Pretty easy stuff. The second thing is ordered pairs. Well, ordered pairs, we know how to do these. We've been doing these for a long time. Ordered pair is just a set of numbers inside parentheses separated by a comma that shows us a specific data point. So first of all, we would just say that at 0.0 seconds, it was 10 feet tall, 10 feet high. At 0.1 seconds, it was 9.8 feet high. At 0.2 seconds, it was 9.4 feet high. And at 0.3, so you see how we're doing this. This one's really not that difficult. And 0.4 and 7.4. Okay, so the first one that we did was the mapping. The next one we did was ordered pairs. The last one, we're going to actually graph this. So if I wanted to graph this, it's going to be a little bit small and hard to see. I think I'm going to make my X scale to be 0.1. That would be a lot easier for me. So the first one would be 0.1, and then 0.2, 0.3, 0.4. Maybe I'll just put out here that this is 0.5. 6, 7, 8, 9, and this would be 1 out here. And then the X scale, I think we'll just keep that, or the Y scale, we'll just keep that at 1. So 0.0 was at 10. So I'm going over 0, left and right 0, and up 10. The next one, 0.1. So I changed my scale, so I'm going to go over to 0.1 and up to 9.8. That's going to be real close to the 10 up there. 0.2 was 9.4. 0.3 was 8.6. And obviously these are kind of hard to graph on this graph. Maybe I should have got one with a slightly different scale, but we know how to graph these. 0.4 was going to be 7.4, somewhere right about there. All right, so we've got the first one was a mapping, the second one was ordered pairs, and the third one was a graph. And here's the main points you got to see. All three of those are giving you the exact same information. They're just coming at you in a different way, but it's the same information, it's the same numbers, it's the same data. All right, let's look at the next one. The next part of this says, what are the domain and the range of the function? Okay, now this is going to be important. The domain is your set of x values. So what are all of the x's? And your range is going to be your set of y values. So what are all of your y's? So your domain, domain starts with a D, I suppose. So the domain is going to be equal to, first x was 0.0, and then 0.1, 0.2, 0.3, and 0.4. That's your domain, your set of x values. Well, what are your range values? What are all of the values for your range? Well, those are your y values. So I think I might start with the smallest and put it in order. 7.4, 8.6, 9.4, 9.8, and 10. That's your range. So domain and range. Domain is simply your x values, range is your y values, okay? Not bad. So far we've got mappings. Just write them in ovals and connect the points that go together. Ordered pairs, parentheses separated by comma. We know how to do that in graphing. Your x and y values. The domain is the set of your set of your x values. Range is your set of y values. And now let's look at this. Determine if each relation is a function. Okay, now here's the textbook definition of a function. A function is where each x has only one y. Each time you put a number into this machine, this function machine, you're going to get the same number out. So, for example, with the example that I put in earlier, that I gave you earlier, if I put a 2 into this machine, I think we got out a 10. And then I put a 3 in and we got out a 15. Well, let's say that I put another 2 in. If we put another 2 in, we would get a 10 again. And if I put a 2 in again, we would get another 10. And every time I put a 2 in, we're going to get a 10. And every time I put a 3 in, we're going to get a 15. So that's what a function is. So what we've got to look for is when we put in the same number and we get a different output. So if I put in a 3 and I get a 15, and then I put in a 3 again and I get a 20, that means it's not a function, because every time I put in that 3, I've got to get out a 15 in my function. Different functions are going to give you different numbers, but let's look at this. So as I'm looking, I'm just going to look at the numbers that I'm putting in. And as I see that, none of those numbers repeat, so this is automatically going to be a function. So let's see. Let's circle our functions in green. This one is going to be a function. Now let's look at the next one. Do any of those x's repeat? Are any of those times when we put in a number for our x, our domain, and we get out a different number for our range? Well, first one is 1, 3, and then 2, 5, and then 3, -1, and 4, 0, and 5, 6. None of these x's repeat, so this one is also a function. That one is also a function. Now, let's go back and maybe let's change this into not a function. Let me show you what it would look like if it was not a function. This one would look like this if it was not a function. All right? And here's what I'm looking at. You see that 4? One time when I put in the 4, I got a 0. And another time I put in the 4, I got a 6. That doesn't work, okay? Every time you get it put in the 4, you either need to get that 0 or get that 6. But if it's a function, it's going to work that way every time. So if that, with those red arrows in there, that would not be a function. That's what a not function would look like. What about if it's ordered pairs? Well, a not function might look like this. You see that 0.62? Let's say that we would also add the 0.67. All right? So now you see the x's are the same, but our y's are different. that means it is not a function, all right? And the number we're really looking at is the x. So if it were 6, if it were 6, 7, it is not a function. What about if it was the number, let's say that it was the number 5, 2. What about that? Is that going to be a function? Because as I look at the point right up above it, 6, 2, the y's repeat. They're both 2's, but that's okay. That doesn't matter. What matters is that the x's don't repeat and give you a different number. So the 5 with a 2 is okay because up here it's a 6 with a 2, and that's fine. Okay, so we're really, if we're 100% honest, we're almost entirely just looking at the x's and see if the x's repeat, okay? See if the x's repeat. And if we see an x that repeats, then just look and make sure that those y's, if it's a function, those y's would have to be the same. If they're different, then it's not a function. So the first key is to find the x's that repeat. All right, so now, looking at this graph down here, this top one right there, is that a function? Well, here's what we use. We use what's called the vertical line test, all right? And if you take, the vertical line says, if you have a vertical line and as you pass it through your graph, if it only touches at one point, it never touches the graph at more than one point, then it is a function. Okay, so we're going to have our vertical line going back and forth, and if it's only touching the graph at one point, that's a function. But if it ever touches at more than one, it's not a function. So right here, for the sake of this video, you're not going to see me moving my pen back and forth, but maybe I'll just draw some vertical lines right there. That vertical line only touches the graph at one point, and it's right there. Another vertical line, that only touches the graph at one point, right there. Another vertical line right here. That only touches the graph at one point. So no matter where I'm drawing that line, it's only going to touch at one point. Let's look at the next one. Let's do more of these vertical lines. Well, right there, only one point. Right here, only touches the graph at one point, and that's right there. How about if I do another one? What about right there? Only one point. It's only touching at one spot. Right? Let's look at the next graph. The next graph, I'm going to draw a vertical line right here. How many places does that touch? Well, it touches this graph right there and right there. It touches 2 places, which means this one is not a function. Okay? Let's go back and do just a real quick review off of this slide. The ordered pairs are a function. However, if I added the ordered pair 6, 7, it would not be a function because that 6 repeats. The x value of 6 repeats, and it gives you different y values. So if it was 6, 7, that would not be a function, but as it was written, it is. The mapping. All right, so with the mapping, as it's written, it is because none of those x's repeat. However, if any of these numbers doubles up and goes somewhere else, then it is not a function. So with that red extra arrow in there, that 3 going to the 1 and the 3 makes it not a function. But how it's written? Yep, that is. Vertical line test. This graph right there, that's a function because it only touches at one point at a time. This one is a function. It only touches at one point at a time. But this circle down here, definitely not a function because that vertical line touches in more than one spot at a time. All right, let's continue. So I want to evaluate this. Now, this is written in function notation, and it's really easy. Another way to write this would be, instead of saying f of x, that's how we read this part, f of x. Instead of saying f of x, I could just as easily say y. Oh, that's an ugly y. I could just as easily say y instead of f of x, all right? F of x, all that means is y. So here's what we've got to do. I want to evaluate f of x or y for 4x plus 1 4x plus 1, and it says x equals 3. So all we have to do is stick the 3 in for the x back here. 4 times 3 plus 1, 4 times 3 is 12, plus 1 is going to be 13. So f of 3 is equal to 13. Okay, f of 3 equals 13. So when I put 3 in, here's what I mean. When I put 3 in for x up here, it's going to give me an answer of 13. Okay? F of 3 equals 13. If I'm evaluating f of x equals 4x plus 1 for x equals 3, I'm going to get the answer 13. So that means f of 3 is 13. So here's what I want to do the next one. F of x equals 2x minus 11 for x equals 5. So I really want to know what's f of 5. All that means is if I put 5 in for x, what am I going to get for y? Is really what this means. So put 5 in for x. 2 times 5, that's going to be 10 minus 11 is equal to negative 1. 10 minus 11 is negative 1. So f of 5 equals negative 1. That's what we've got. All right, so those are a little bit tricky, but not too bad. Let's do some word problems. Write a function rule that produces an output of 7 for an input of 1.5. So here's what that means. I'm going to put 1.5 into this function machine, and then I'm going to do something, and I'm going to get an output of 7. So what could I do to 1.5 to make it equal 7? Well, something really easy. Let me just write these in blue. I could add 5.5 to it, because 1.5 plus 5.5 equals 7, and that's probably just the easiest thing to do. But I could get crazy with this. I could multiply it times 4 and then add 1. I could do that. Or I could, what else could I do? You know what? I could do really crazy. I could multiply this by 6. 1.5 times 6 is 9, and then subtract 2. So there are lots of different ways that I could do this. All right, I could keep going forever, but the easiest way would probably just be to add 5.5. 1.5 plus 5.5 equals 7. All right, now here's the thing. It's not always going to be 1.5. In this problem it is. It says 1.5, but when we're looking for a rule, I want something that's going to be always true. So it's not always going to be 1.5. So what do we do if it's not always 1.5? We could just call that x. So instead of 1.5 here, I'm going to think of this as an x. All right? And if that x happens to be 1.5, it's going to be 7. But if it's not 1.5, it's going to be something else, and we could just call that y. Or in this case, since it asks for a function rule, instead of y, we could maybe write f of x. All right, now let me write this final answer up here. F of x equals x plus 5.5. Let's see if it works. If I put 1.5 in for x, am I going to get an output of 7? 1.5 plus 5.5? Yeah, I sure do. Let's write some of the other ones too. F of x, we could say, is equal to 4 times x plus 1. That was this one right there. Or let's write this bottom one as a function rule. F of x equals, this 1.5, that was our x, right? So this would be 6 times x minus 2. All right, so any of these would work, but like I said, without a doubt, the easiest one is going to be the top one. All right, that's the easiest one. Let's look at one more. A cable company charges a monthly fee of $24.50 for cable service. There's an additional monthly fee of $3 for each premium channel. George has a cable service with 4 premium channels. Write and evaluate a function, just think equation, to find the monthly cost of George's cable service. Now, we read this quick, but there was a huge, extremely important word that when you see this, you should cheer. Maybe don't cheer in class. Kids will think you're weird, honestly. But cheer in your head, like, yes, I see it, I got it. For each, okay? Each, every, per means to multiply, okay? So this is golden. Watch this. I know each means to multiply. So let's just write what this says here. $3 times for each premium channel. Now, let's just call it P or C. P for premium, C for channel. I don't care. Maybe I'll use a P. I'll use P. So 3 times P. But then, so that's all of this. We've got all of this taken care of. But what else did we have? Well, that was an additional fee. We also had to pay $24.50 for just the monthly service. Okay. 3 times P, $3 for each premium channel, plus the $24.50 for the monthly service. And this is going to be equal to, let's just say that the cost is equal to 3 times P, all right? Now, it did say to write a function, okay? So instead of C here, we would just call this f of P. The function of P is 3 times P plus $24.50. Now, it says here, look back up here, it says that he has 4 premium channels. First of all, this is our answer to the first part, where it says to write a function. Now let's evaluate. It says he has 4 premium channels, so let's put 4 in for P. 3 times 4 plus $24.50. Okay, 3 times 4 is 12 plus $24.50. So f of 4 premium channels, is going to be 12 plus $24.50, $36.50. That's what that's going to be. All right? So that's it. Everything you need to know about functions. Well, maybe not everything you need to know about functions, but we're getting there.